Welcome guys to my YouTube channel, which is Rare Science Simple, and let's make the science simple. So currently I am giving lectures on the population genetics series, and this is my fourth lecture. If you have not watched my previous lectures on population genetics, please do watch these videos. And let's start this new topic on population genetics, which is the interdeme selection or the kin selection. So first of all, we need to understand what are the subdivided population. So subdivided population, whenever the original population is dividing into two or more populations, that is known as the subdivided population, and that results in the formation of the new populations that are genetically distinct. And how the population subdivision can occur? It could be caused because of the geographical variance such as mountains, valleys or rivers. They separate the original population to multiple populations. The individual component populations are known as demes, and we will discuss it in my next slides. And metapopulation is the collection of population that are made up of demes. So for example, in this case, if you will see, this is your main population, and because of some river, it is divided into two population. This is population 1 and this is population 2. You can see these are the subdivided. Both of these populations are subdivided population. Okay, and now we will understand what are the demes. So let's see, this is your main population. This is your main population. Now it has been divided into multiple subpopulations, and these subpopulations are known as demes. Can you please count the number of demes in this population? So this is like 1, 2, 3, 4, 5, 6, 7, 8. So there are total, how many demes are there? 8. There are the total number of demes in this picture is 8. And what is metapopulation? Is the collection of the population that are made up of demes. Now you collect all of these demes. This is known as the metapopulation. Okay. So now see this. The individual component populations are called demes. So you can see this is deme, this is deme. So individual component population is known as demes, and metapopulation is the collection of population that are made up of demes. So all of these demes will constitute and make the metapopulation. So this is the difference between the metapopulation and demes. So now we know that according to the Darwin, the more fit the individual is, that is going to be survive. The phenomena or they call this process the survival of the fittest. But this is not going to happen always due to the altruistic behavior. Okay, in case of the altruistic behavior, what happened? What happened if this is the particular organism, let's say, and these are its close relatives. Then even though any trait which is harmful to this individual may be harmful to this individual, may be harmful, but it is going to be beneficial for the others. So whenever it is beneficial for the others, then the nature select this trait. Again, this trait is going to be decided by the genotype of this particular individual. So whatever the genotype is harmful for this particular individual but beneficial for the others, then this behavior is known as the altruistic behavior, and nature select the altruistic behavior or the altruistic genotypes also. So you can say the nature select altruistic genotype, altruistic genotype. Okay, so now with this note we will, and this is like in the case of close relation, so this is known as the kin selection, you can say this is known as the kin selection. So this is at the individual level, but in case of the interdemes, like we see there are 8 interdemes. So in this there are individuals living in this, or these not need to be individuals only, these could be insects and some other things also. So whenever the trait is useful in between the demes, useful in between demes, then this is known as the interdeme selection. So what does it mean? The trait could be harmful for this particular deme, but it's beneficial in between the demes. So it is not at the individual label, it is at the label of demes. So now let's read this. It means having or showing an unselfish concern, even though it is harmful to you, that is okay, but nature is going to select that trait because it is useful for the others, for the welfare of others. It means having or showing an unselfish concern for the welfare of others. It can also refer to the animal behavior that may be harmful to the animal itself but benefits others of its species. As you know, the example of honeybee. And also some insects give some horn to other close relatives so that the predator cannot attack them, but because they are making that sound, predator can attack that particular insect, so that is harmful for that insect but is beneficial for the other insects. So nature select these kind of genotypes, or this behavior is known as the altruistic behavior. So there are two mechanisms that have been used to explain the evolution of the altruistic characters. One is the kin selection and one is the interdemic selection. What happened in the case of the kin selection, as I said, it is at the individual level. There should be the close relationship between the two individuals. So it is a theory in natural selection that describe how altruistic behavior can evolve when they benefit an organism's relative. Means if you have your relative, you are even though that particular trait is harmful to you but is beneficial for the others, nature will select that, even if it comes at the cost of the organism's own survival and reproduction. So this is the unselfish concern. So selection is occurring. Why? Because it is beneficial for the others level. Or selection occur for the trait that is not beneficial to the organism that carry that, but is beneficial to the organism's relative. And the best example is the honeybees example. The workers sacrifice their lives because of the protection of their queen. Similarly, in case of the some insects that is making some horn, that is giving some signal to their relatives that the predator is going to attack them, but because they are making sound, the predator can attack that particular insect itself. So that is harmful to that particular insect that is giving the signal, but is beneficial for the others trait, for the others close relatives. So how this happened? So whenever there are two individuals, like, right? So in this case we can see here what happened. Suppose this is the individual and these are some close individuals. So what happened if loss, this is known as the benefactor, or you can say it's a donor, or these are the beneficiaries that are going to be benefited. This is beneficiaries. What happened when a particular trait may be harmful to this benefactor but is useful for the other beneficiaries, then there is going to be the kin selection. And the one thing is they need to be relative. They should relate to each other. Then only they can show the unselfish behavior. So whenever the gain in fitness of the beneficiary, which is this one, when the gain in fitness of beneficiaries is higher than the loss in fitness of benefactor, then the kin selection occurs. Whenever, and it should be always inversely proportional to the coefficient of relationship between them. If they are very very close, then the kin selection may not occur. But if the closeness is not very much high, then the kin selection is going to be occur. Means if you are not too much closely related, and the gain in the fitness of beneficiary is high in comparison to the loss in fitness of benefactor, then the kin selection is going to be occurred. So let's see this. What is the coefficient of relationship? The coefficient of the relationship is the measure of how closely related two people are. So if they are not very close, or you can say the less close relation, and gain in fitness will select the allele for the altruistic behavior, even though it may be harmful to the benefactor. So what are the things which are important? The gain should be high in the beneficiary in comparison to the loss in fitness of the benefactor, and the closeness should not be too much high. Okay, in that case the nature will select that particular altruistic genotype. In this case, alleles determining the altruistic behavior would have a selective advantage within the breeding population. And then comes to the interdeme selection. So what is the difference between the kin and interdeme? In the kin selection, relationship is necessary, but in the interdeme selection, you require only the subdivided population, and close relationship is not necessary or mandatory. This is the difference. It operates on the genetic variance among demes rather than that individual level. As I said before, the population at large is known as the metapopulation, which consists of the multiple demes, each of which may expand, contract, extinct, and in this way it will contribute to the recolonization. If the probability of the deme survival or the deme capacity for numerical expansion increases with their frequency of the altruistic allele, then such alleles could have a selective advantage in the metapopulation. However, interdemic selection would not lead to the selective advantage for the individually deleterious allele within the deme. So let's see this diagram here. So these are the demes, 8 demes. Whenever the altruistic genotypes are beneficially for not in within demes but in between demes, then there is going to be the interdeme selection. So these are the 2 demes, and the selection will occur if the particular altruistic behavior is advantageous in between 2 demes, not just for the individuals which are living within demes. So this was the case, you can read here. Interdemic selection would not lead to the selective advantage for the individually deleterious allele within the deme. So it should be interdemic, means in between the demes. That's what the thing you need to understand. In the interdemic selection, one allele may be harmful to the organism within demes, but should be the favorable to the deme as a whole. Okay. So interdeme means in between demes. The selection is going to occur whenever the particular trait or particular genotype is beneficial for the organism that are living in different demes. So what is the difference? The kin selection requires association between the related individuals. Interdemic selection requires subdivided population and does not require associations among related individuals. So in part, if I will say, the selection will occur if it is advantageous for the organisms that are living in different demes. So this is the total change in gene frequency that you can, if you know the change in frequency within demes and in between demes, you can calculate the delta Q. Whenever the delta Q is more than 0, and there is going to be the interdeme selection, and it will happen why? Whenever the B minus C divided by C is more than 1 minus F by 2F. So what is B? That is the fitness of the recipient, or you can say the beneficiary. So this is the recipient, or you can say the beneficiary. Fitness of the altruistic means this is the benefactor, and this is the inbreeding coefficient, how they are breeding in between them. So this formula is like this: B minus C should be more than 1 minus F by 2F. And you know the formula of F. So, okay. Formula of F is 1 minus what F is equal to 1 divided by 1 plus 4m. So, so what happened if you substitute these values? You will get 1 minus 1 by 1 plus 4m nm divided by 2 into 1 divided by 1 plus 4 nm, right? So if you calculate this, you will get 1 plus 4 nm minus 1 divided by 2, and then is going to be 1 plus 4 nm. Okay, so when you will solve this equation, you will, this is going to be cut off, this is going to be cut off, it will come like 2 nm. Okay, so this is the thing which you are going to get here, 2 nm. So what is n? N is the number of is the effective population, and m is the mutation. Oh yeah. So you can see whenever B minus C by C is more than 2 nm, then there is going to be the interdemic selection. Okay, or you can say whenever the B, it means the beneficiary fitness of the recipient is more than the fitness of the donor, then there is going to be the interdeme selections. So we therefore can conclude that selection between demes, remember this word is very important, in between demes, not within demes, overrides selection within demes only when the benefit to the group, which is B minus C, that is the net benefit, is and relate with the when the benefit to the group related to the cost of the individual organisms is greater than the average number of migrant organisms per generation. And this is denoted by the N. N is the average number of the migrant organisms. Okay. So in that case, the interdemic selection is going to be occur. So you need to remember this formula: B minus C by C should be higher than 2 and m. And where what is n? N is the number of migrant organisms per generation, because whenever there is a migration, then only there is going to be the subdivided population you can see. So how will you decide the degree of differentiation between the subdivided population? So that is being decided by this FHT is equal to HT minus HS by HT. What is HT? This is the expected heterozygosity of the total population. What is HS? It is the average expected heterozygosity of the subpopulation. So whenever the FHT is 0, how it is going to be 0? It is going to be 0 when HT is equal to HS. Then you will see FST will equal to 0. And whenever they are 0, it means the population have the identical allele frequencies. And whenever the FST is 1, it means HS is 0. In that the population is fixed for the different alleles. In the subdivided population, that particular allele is completely lost. So that is how you can determine this or you can calculate the degree of differentiation between the subdivided population, or you can say between the DIMS. Okay, so this is all about this lecture, and to summarize it, I just want to tell you two things which you need to remember. What are DIMS? So this is the population. Whenever this population is divided into many populations, this is known as the these populations are known as the subdivided populations or DIMS, and collectively they make the meta population. So this is number one thing. And the second thing which you need to remember is that nature will not always select the survival of the fittest organism. It can also select the genotype that may be harmful to the particular individual or to the individuals which are living in a particular DIM, but is advantageous for the closely related individuals or the individuals living within DIMs. So these are the two things which you need to remember. Whenever the gain in fitness is high and loss in fitness is less, and it is inversely proportional to the coefficient of relationship, it means if there is a less close relationship and gain in fitness, both are high, then the nature will select and that particular trait in the process of kin selection. Similarly, similar things will occur in case of the inter-DIM selection. Inter-DIM selection occur also, you can see whenever the B minus C is higher than the C and higher than the average number of migrant organisms per generation, then the nature will select that particular trait and that will lead to the inter-DIM selection. So that's all about my lecture, and if you like this lecture, do subscribe my channel and also watch my previous videos on the population genetics. Thank you so much.